Hello everyone, and welcome. Have you ever wondered how massive chemical plants work? How they manage to move millions of liters of liquids and gases safely and efficiently every single day? The secret lies in a core engineering principle known as fluid mechanics. Today, we're going to explore what fluid mechanics is and why it's absolutely crucial for every chemical engineer. At its heart, fluid mechanics is the science of fluids, which includes both liquids and gases, and how they behave when they are at rest or in motion. Chemical engineers are essentially process designers. They create systems to transform raw materials into valuable products, and almost every single one of these processes involves moving fluids. That's the connection. Fluid mechanics provides the tools to understand and control these fluids. Let's break it down into a few key areas. First, it's all about transport. Engineers use fluid mechanics to design the entire circulatory system of a plant. This means calculating the right pipe size to carry a certain amount of liquid, preventing bottlenecks, and figuring out how much pressure is lost as a fluid travels over long distances. Second, it's about the machinery. A chemical engineer needs to select the perfect pump or compressor for the job. Do you need to move a thick, viscous fluid like syrup, or a thin fluid like water? Fluid mechanics helps determine the power needed for the pump and the type of pump that will work most efficiently, saving energy and money. Third, we have process equipment design. Think about a chemical reactor where you need to mix two liquids together. An engineer uses fluid mechanics principles to understand the flow patterns inside the reactor to ensure the chemicals are mixed thoroughly and react completely. Another great example is a distillation column, where liquids and vapors flow past each other to be separated. The entire design of these columns is governed by the principles of fluid flow. We also look at different types of flow, like smooth, predictable laminar flow, versus chaotic, messy turbulent flow. Understanding which type of flow you have is critical for processes like heat transfer and mixing. So, in short, fluid mechanics isn't just an abstract physics topic for chemical engineers, it is a fundamental, practical toolkit used every day to design, operate, and troubleshoot the equipment that moves, mixes, heats, cools, and separates materials. Without it, a chemical plant would just be a collection of disconnected tanks. And that's a quick look at the vital role of fluid mechanics in chemical engineering. It is the science that turns a static design into a dynamic, functioning process. Thank you so much for watching. If you found this explanation helpful and want to learn more, please consider liking this video and subscribing to the channel. Your support really helps us create more educational content. We'll see you in the next one.